we're going to go through the main types of plate boundaries. Plate boundaries. These plate boundaries are the places where two tectonic plates join together. And we're going to call this notes. And in your notes, always put the date. So today is 10/8/2013. So the first type of plate boundary is called divergent. Divergent. I'd like you to write this down as I write it down. In your textbook, it talks about divergent boundaries, and we'll just draw this boundary here. And divergent boundaries show up where two plates are moving apart. Two plates moving apart. And generally we find these boundaries where there is magma from the mantle that is rising up in convection currents, and those convection currents form an area where magma comes up and pushes two plates apart. And generally, these types of boundaries are found along areas where there is a mid-ocean ridge and a mid-ocean trench. And the trench is oftentimes very deep, and because of the temperatures of the molten magma coming up down here, it produces a really unique environment where creatures are found that don't normally live in any other area but the mid-ocean trench. Because it's warm and because it's super deep, it's a very unique environment. And so these two types of plates here, divergent means that these two plates are moving apart. So this plate is going this way, and this plate is going this way. So this, of course, is the crust here, and this down below is the mantle. Now, places where this is found are places like the middle of the Atlantic Ocean, the middle of the Pacific, and of all places in Greenland. Greenland is one of the places where it is found on land instead of in the ocean. Okay, so the first type of boundary is divergent. The next type of boundary, yeah.
Is there any in Iceland, or is it just Greenland?
Iceland too, yeah. The next type of boundary is called convergent. And guess what that's moving together? Instead of moving apart, it's moving together. And the first type here is where you have an ocean plate and a continental plate. Ocean and continent. And here's what it looks like. Here is an area where you have one plate. This is the ocean plate. And it's diving beneath the continental plate. This is the continental plate. And what happens, this is called, have any of you read about this yet in the book? What is it called, Georgia?
Not that, but what's the fuzzy thing above the ocean?
That's the water. This is called subduction. And it happens when a dense ocean plate, this is really super dense, and this is less dense, the continental plate is less dense, dives beneath the continental plate. And what happens in this kind of situation is that you get high heat and pressure down deep in the earth, and that creates melting of the rock, which forms volcanoes. Volcanoes. So there's the volcano. Now, this is happening right here in our area. This is happening right here in our area. And this right here could be, for instance, Mount Whitney, Mount Hood, Mount Lassen. So we're going to call this Mount Lassen. And sometimes you get coastal mountains forming right here close to the coast. This is Loma Prieta. Loma Prieta. That's actually a squished up O because it's coming together and squishing. So this plate is coming this way, and this continental plate is coming this way, and they're crashing together. They're crashing together. And oftentimes you'll get a deep ocean trench out here. We have the Monterey Bay Submarine Canyon, but that was mostly cut by rivers and stuff like that. But the Aleutian Islands, the Aleutian Trench off of Alaska, that's how that was formed by the Pacific Plate and the North American Plate coming together. So this could be the Pacific Ocean Plate. And this could be the North American continental plate, where we are now, where Loma Prieta is. Okay. Finish up this continent right here. So, down here, it's high heat and temperature, or high heat and pressure, that is. So heat and pressure are great where two continental plates come together. So I'm going to draw an arrow up. That means high or great, or a lot. So high heat and pressure down deep in the earth here, creating the melting of the rock and the magma that forms this volcanic ridge that runs all the way to Alaska. Okay, does that make sense? Okay.